Welcome to SwiftUI Codes. In this lesson, you'll create your very first iOS app. You'll learn about the view protocol, body property, text views, and basic modifiers. By the end, you'll understand the fundamental building blocks of every SwiftUI application. Welcome to SwiftUI. Get ready to build your very first iOS app. This is where your journey begins. Every SwiftUI file starts with this magic line: import SwiftUI and unlock a world of possibilities. Now we create a struct called content view that conforms to the view protocol. Every screen in SwiftUI is a view. Inside our struct, we need a body property. This is where we describe what our view looks like. Let's add a text view. Text is the simplest way to display words on screen. Watch the preview on the right. Let's change our text to say, "Hello SwiftUI." See how the preview updates instantly. Now let's make it bigger. Adding .font.large title makes our text much larger. This is called a modifier. Let's add color. The foreground style modifier changes the text color. We're using blue here. Beautiful. Congratulations, you've just built your first SwiftUI view. The key concepts are struct, view protocol, body, text, and modifiers. In this lesson, you'll master text styling in SwiftUI. Learn about font sizes, weights, and designs. Discover how to apply colors, gradients, and create stunning typography. By the end, you'll be able to make any text look absolutely beautiful. Typography is everything in design. Let's make your text absolutely stunning. We start with a simple text view displaying the word SwiftUI. Adding font title makes it larger. SwiftUI has built-in font sizes: title, headline, body, caption, and more. For custom sizes, use font system size. Here we set it to 48 points, much bigger now. Add weight bold to make it thicker and stronger. See how the text becomes bolder? Or use ultralight for a thin, elegant look. The text becomes very delicate. The design parameter changes the font style. Rounded gives us soft, friendly corners. Let's add a purple color with foreground style, looking great. But here's the magic. We can apply a gradient to text. Linear gradient blends purple to pink. Absolutely stunning. You've learned font sizes, weights, designs, colors, and even gradients. Typography is the foundation of great design. Time to paint your interface. In this lesson, you'll explore system colors, custom colors, and gradients. Learn to create linear and radial gradients that make your app pop. By the end, you'll add vibrant colors and smooth transitions to any view. Time to paint. Colors and gradients will make your app pop. Let's get creative. We'll use a rectangle shape to demonstrate colors. By default, it fills with the foreground color. The fill modifier applies a color. Red is a built-in system color that adapts to light and dark mode. Change it to blue. SwiftUI has many system colors: red, orange, yellow, green, blue, purple, and more. Mint is a fresh, modern color. These semantic colors look great in both light and dark mode. Now let's create a gradient. Linear gradient blends colors in a straight line. Blue flows into purple from left to right. Change the direction. Top to bottom creates a vertical gradient. The flow direction changes completely. Add more colors. Cayenne, blue, and purple create a smooth three-color blend. Diagonal gradients feel dynamic. Radial gradient radiates from the center outward. Yellow in the middle fades to orange. Perfect for glowing effects. You've mastered colors and gradients. Use them to create depth, highlight elements, and make your app beautiful. Apple provides over 5,000 free icons for your apps. In this lesson, you'll learn to use SF symbols with different sizes, colors, and rendering modes. By the end, you'll add professional icons to any interface without any external resources. 5,000 free icons. Apple's SF symbols library is a treasure chest. Let's dig in. To use an SF symbol, create an image with system name. Here's a simple star icon. Add .fill to get the filled version. Most icons have outline and filled variants. SF symbols scale with font size. Making it 60 points creates a large, crisp icon. Add color with foreground style. A yellow star looks natural and eye-catching. Try a different icon. Heart fill with red color. Perfect for a like button. Some icons have multiple layers. Cloud sun fill can have different colors for the cloud and sun. Or use multicolor mode. This shows Apple's designed colors. Weather icons look realistic. There's even a Swift logo. SF symbols includes programming icons, devices, and much more. Download the free SF Symbols app from Apple to browse all 5,000 plus icons. They're vector graphics that scale perfectly. Let's make your app interactive. In this lesson, you'll create buttons that respond to taps, learn about state variables, action closures, and button styling. By the end, you'll build fully interactive user interfaces that respond to user input. Time to make things interactive. Buttons are the gateway to user engagement. A basic button has a label and an action. The label is what users see. The action runs when tapped. Inside the curly braces, we write code that runs on tap. Here we print a message. To track values that change, we use its state. This creates a variable that SwiftUI watches. Now we display the count in the button label. Each tap increases the number. Try it. Style the button with modifiers. Font title makes the text larger. Padding adds space inside the button, making it easier to tap. Add a blue background and white text. Now it looks like a real button. Clip shape with capsule creates rounded pill-shaped buttons, professional and modern. You've built an interactive button with its state. This is the foundation of all SwiftUI interactivity. Stacks are the building blocks of every layout. In this lesson, you'll master VStack, HStack, and ZStack. Learn about spacing, alignment, and layering views. By the end, you'll be able to create any layout you can imagine using these three powerful tools. Stacks, the building blocks of every layout. Master these three and you can build anything. VStack stands for vertical stack. It arranges views from top to bottom. Let's add our first text view inside the VStack. Add a second text. See how it appears below the first one? That's vertical stacking. Add a third. They stack vertically one after another, simple and powerful. Add spacing to control the gap between items, 20 points of space between each view. Stack is horizontal stack. Views arranged from left to right, side by side. Spacer pushes views apart. It expands to fill available space. Left goes to the left edge, right to the right. Z-stack layers views on top of each other. The circle is behind, text is in front. Great for overlays. V-stack for vertical, H-stack for horizontal, Z-stack for layers. These three stacks build any layout. This is how real apps are built. In this lesson, you'll create scrollable lists and navigation flows. Learn about navigation stack, navigation link, and list views. By the end, you'll build multi-screen apps with professional navigation patterns. Lists and navigation. This is how real apps are built. Every major iOS app uses these. List creates a scrollable container. It automatically handles scrolling and styling. Add items inside the list. Each item becomes a row. Add more items. List automatically adds separators and proper spacing between rows. You can put any content in list rows. Here we add icons with text. Wrap the list in navigation stack to enable navigation features. Add a title with navigation title. It appears at the top of the screen. Navigation link makes rows tappable. Tapping pushes a new screen. This is how you navigate between views. Lists and navigation stack are the building blocks of most iOS apps. Master these and you can build anything. Discover the secret sauce of SwiftUI. In this lesson, you'll master state and binding for reactive interfaces. Learn how data flows through your app and updates views automatically. By the end, you'll understand the core concepts that power every SwiftUI application. The secret sauce of SwiftUI, state and binding make your UI come alive. If we create a regular variable, it won't update the view when changed. This is static. Add its state before the variable. Now SwiftUI watches this value. When it changes, the view updates. Let's put our content in a V-stack so we can add a button below. Add a button that increments count. When tapped, count changes and SwiftUI redraws the text automatically. Make the count bigger with font large title. The state still works the same way. State works with any type. Here's a Boolean for a toggle. Notice the $sign before eyes on. The $sign creates a binding. A binding is a two-way connection. The toggle can read and write the value. At state owns the data. At binding borrows it. Use $sign to create bindings. This is SwiftUI's data flow. State and binding are the foundation. Master these and you'll understand how all SwiftUI apps work. Make your app magical with animations. In this lesson, you'll learn with animation, spring effects, scale, rotation, and transitions. By the end, you'll create smooth, delightful animations that make your app feel alive and professional. Animations. This is where your app becomes magical. Prepare to be amazed. Let's animate a circle. We start with a scale state variable set to 1. Scale effect changes the size. When scale is 1, it's normal size. 2 would be double size. On-tap gesture runs code when tapped. We set scale to 1.5, but watch, it changes instantly, no animation. Wrap the change in with animation. Now the circle smoothly grows to 1.5 times its size. Magic! Add .spring for a bouncy effect. Spring animations feel natural and delightful. You can animate any property. Here we animate rotation. Each tap spins the circle 360 degrees. Transitions animate views appearing and disappearing. Scale makes it grow in and shrink out. With animation is all you need. SwiftUI figures out what changed and animates it. Simple and powerful. Project time. In this lesson, you'll build a complete weather app using everything you've learned. Combine gradients, icons, animations, and state management into a beautiful functional app. By the end, you'll have your first portfolio-ready SwiftUI project. Project time. Let's build a beautiful weather app using everything you've learned. Start with a ZS stack. We'll layer a background behind our content. Add a beautiful sky gradient, blue at top fading to cyan. Ignore safe area, makes it full screen. Add a V-stack on top for our weather content. This will hold all our information. Add a weather icon. Sun Max Fill with multicolor rendering shows a bright, realistic sun. Display the temperature. A huge, thin font looks elegant. This is 24 degrees. Add the city name below. Font title 2 is a good size for secondary information. Wrap it in a card. Ultra-thin material creates a frosted glass effect. Clip shape rounds the corners beautifully. Add interactivity with state. Toggle between day and night. The icon and gradient change with animation. Excellent work. You've completed the weather app project. Now, let's move to more advanced topics. The journey continues. Every app needs user input. In this lesson, you'll master forms, text field, secure field, toggle, slider, and picker. Learn to build login screens, settings pages, and registration flows. By the end, you'll create professional forms that capture any type of user data. Forms, the backbone of every app. Login screens, settings, signups, let's master them all. The form container automatically styles its contents for input. It creates that familiar iOS settings look. Text field lets users type text. We bind it to a state variable with the $sign. Whatever they type goes into name. Add an email field. The keyboard type modifier shows an email-optimized keyboard with the @ symbol easily accessible. For passwords, use secure field instead. It hides the characters with dots, keeping user data private and secure. Toggle creates a switch, perfect for Boolean choices like agreeing to terms, enabling notifications, or dark mode. Slider handles numeric ranges beautifully. Drag to select a value. We display it below in real time. Picker presents multiple choices. Users tap to select. For each creates options from an array, clean and dynamic. Section groups related fields together with headers. This creates visual hierarchy, making forms easy to scan. That's forms mastered. You now know text field, secure field, toggle, slider, picker, and sections. Perfect for any setting screen. Build apps with that iconic bottom tab bar. In this lesson, you'll create tab views with multiple screens, custom icons, and selection binding. Learn to combine tabs with navigation for complex app structures. By the end, you'll build apps like Instagram, Twitter, and more. Tab bars, that iconic row of icons at the bottom of every great app. Let's build one. TabView is the container for your tabs. Each child view becomes a tab. Simple concept, powerful results. Each view needs a tab item modifier. Inside E, an icon and label. Home tab is ready with a house icon. Add a second tab, search with magnifying glass icon. Users can now switch between home and search by tapping. Real apps have separate view structs for each tab. Add profile, and you've got a 3-tab navigation. Control which tab is active with selection binding. Each tab gets a unique tag. Now you can programmatically switch tabs. Combined with navigation stack, each tab can have its own navigation hierarchy. push and pop views within each tab. Customize the tab bar color with tint, purple, blue, any color. Match your app's brand identity. Pro tip: label combines icon and text in one line. Clean, readable code. This is the standard app structure. TabView complete. You can now build multi-screen apps with professional bottom navigation. Every major app uses this pattern. Become a digital artist. In this lesson, you'll learn to draw custom shapes with Path and the Shape protocol. Create triangles, stars, curves, and any shape you imagine. By the end, you'll design unique icons, logos, and graphics for your apps. Become a digital artist. Draw any shape you can imagine with custom paths. Custom shapes conform to the Shape protocol. You implement Path in returning a path that describes your shape. Create a path variable. This is like picking up a pen, ready to draw. We'll return it when done. Move to the starting point, top center of the rectangle. Mid-X is horizontal center. Min-Y is the top edge. Draw lines, first to bottom right corner, then to bottom left. We're tracing the triangle's edges. Close the path. This draws the final line back to the start. Our triangle is complete. Use it just like any shape. Fill with color, set frame size. Our custom triangle works perfectly. Or use stroke for an outline. Line width controls thickness, same shape, different style. For curves, use add curve. Control points shape the bend. This creates smooth, Bezier curves. Draw anything imaginable. Custom shapes unlocked. You can now create unique icons, logos, and graphics. Paths are the foundation of all visual design. Make your app respond to every touch. In this lesson, you'll master tap, long press, drag, rotation, and magnification gestures. Learn to combine gestures for complex interactions. By the end, you'll create intuitive touch experiences that users love. Touch magic. Make your app respond to taps, drags, pinches, and more. So satisfying. The simplest gesture. On-tap gesture runs code when users tap. Quick, responsive feedback. Add count parameter for double tap or triple tap with count 3. Instagram uses this for liking photos. Long press gesture. Hold your finger for a moment. Then the action triggers. Perfect for context menus. Drag gesture is powerful. Track finger movement with on changed. The circle follows your finger across the screen. On-ended fires when they lift their finger. Spring back to center. Smooth, satisfying animations. Rotation gesture. 2 fingers twist to rotate. Works with rotation effect modifier. Perfect for image editing apps. Magnification gesture. Pinch to zoom in or out. Combined with scale effect, you get smooth zooming. Combine gestures with simultaneously. Drag and rotate at the same time, or use sequence for one after another. Gestures mastered. Tap, long press, drag, rotate, magnify, and combine them. Your app now responds to every touch. Build pixel-perfect responsive layouts. In this lesson, you'll use GeometryReader to access size and position information, create proportional layouts, detect orientation, and build truly adaptive interfaces. By the end, your apps will look perfect on any screen size. Size Detective. GeometryReader reveals dimensions for pixel-perfect layouts. GeometryReader gives you a geometry proxy. This contains size and position information about the available space. Access size.width and size.height exclamation mark. Now you know exactly how much space is available. useful for calculations. Make a circle half the container width. Multiply size by 0.5. It adapts to any screen size automatically. Create a 70-30 split layout. Blue takes 70%, green fills the rest, perfect for sidebars and split views. Track scroll position. Frame and global gives position on screen. Create parallax effects as users scroll. Detect orientation. Compare width to height. Show H-stack in landscape, V-stack in portrait. True responsiveness. Create reusable extensions. A proportional frame modifier you can use anywhere. Clean, maintainable code. GeometryReader complete. You can now build layouts that adapt to any screen size, orientation, or container. Responsive design mastered. Connect your app to the world. In this lesson, you'll fetch data from web APIs using Async await. Learn URL session, JSON decoding, and error handling. By the end, you'll load real data from the internet and display it beautifully in your app. Connect to the world. Fetch data from APIs and make your app truly dynamic. First, define your data model. Codable lets Swift automatically convert JSON into your struct. Clean mapping. Create a state array to hold users. The async keyword marks our function as asynchronous. It can wait for network responses. Create a URL from a string. Guard unwraps it safely. If the URL is invalid, we exit early. Safety first. URL session fetches data. Await pauses until the response arrives. Try-catch handles network errors gracefully. Decode the JSON. JSON decoder converts raw data into user objects assigned to our state array. The UI updates automatically. The task modifier, it runs async code when the view appears, perfect for loading data on screen entry. Add loading states. Show progress view while fetching. Users see a spinner, then content appears. Professional UX. Async networking complete. You can now fetch data from any API, decode JSON, and display it beautifully. The internet is your database. Share data across your entire app. In this lesson, you'll master environment and observable objects. Access system settings like dark mode and dynamic type. By the end, you'll implement global state management and create apps with consistent theming. Global power. Share data everywhere without passing it through every view. Create an observable class. This holds shared settings. Observable makes SwiftUI watch for changes automatically. At the app root, create settings and inject with environment modifier. Now every child view can access it. In any child view, use at environment to access settings. Changes here update the entire app. True global state. Use settings anywhere. Font size and accent color from your global settings. Change once, updates everywhere. SwiftUI has built-in environment values. Color scheme detects dark mode. Dynamic type size for accessibility. Dismiss closes sheets. The dismiss environment value, call it like a function to close the current view. No delegate patterns needed. Override environment values. Force large text for testing. Environment flows down through all child views. Environment mastered. Share state globally, access system values, and override them when needed. Clean architecture for any app. Stop repeating yourself with custom modifiers. In this lesson, you'll create reusable view modifiers for consistent styling. Package complex modifier chains into single, clean calls. By the end, your code will be dry, maintainable, and beautifully organized. Stop repeating yourself. Create reusable modifiers that make your code beautiful. You write these same modifiers over and over. 6 lines for a styled button. Repeat it everywhere. Let's fix that. Create a view modifier struct. The body function receives content. That's whatever view you apply this to. Move all your modifiers inside. Now they're packaged in a reusable component. Define once, use everywhere. Apply with the modifier function. 1 line instead of 6. Your code is cleaner and more maintainable. Even cleaner, create a view extension. Now it reads like a native SwiftUI modifier. Beautiful API design. Modifiers can have parameters. Elevation controls shadow size, customizable yet consistent. Expose the parameter in your extension. Default value of 5, but override when needed. Flexible and expressive. Custom view modifiers complete. You now create reusable, parameterized styles. Your codebase stays clean and your designs stay consistent. Level up to professional architecture. In this lesson, you'll implement the MVVM pattern separating models, and views. Write testable, maintainable code that scales. By the end, you'll structure apps like a senior iOS developer. Level up to Pro. MVVM is how the best developers organize their code. Let's go. Without architecture, views become bloated. State logic and UI all mixed together. Hard to test, hard to maintain. Model is pure data. No UI code, no logic, just the shape of your data. Clean, simple structs. View model holds all your state and logic. Observable makes it reactive. The view watches this for changes. All business logic lives in view model. Fetch, delete, update, all here. The view just displays the results. View is now pure UI. It observes the view model and renders. No business logic here. Clean separation. Testing is simple. Create view model, call methods, check results. No UI involved. Fast, reliable tests. Organize your files by role. Models folder, view models folder, views folder. Everyone on your team knows where to find code. MVVM complete. Model holds data, view model holds logic, view holds UI. Professional architecture for scalable apps. You're a real iOS developer now. Boss level. In this lesson, you'll build a complete task manager app from scratch. Combine MVVM, forms, lists, state management, and beautiful UI. By the end, you'll have a fully functional app demonstrating professional development practices. Boss level. Build a complete task manager app using everything you've learned. Start with the model. A task has ID, title, completion status, and priority. The enum gives us type-safe priority levels. View model manages all tasks. Add task creates a new task and appends it. The view will update automatically. Toggle completion finds the task and flips the Boolean. Delete removes it from the array. Clean, testable logic. The main view, navigation stack for title and navigation. List displays tasks. For each loops through them all. Task row component. Checkmark icon shows completion. Strike through text for done tasks. Priority badge on the right. Tap to toggle. Add task sheet. Form with text field and picker. Environment dismiss closes it. Toolbar save button adds the task. Add a plus button in the toolbar. Tapping shows the sheet, all controlled by the view model. Beautiful interaction. Amazing! You built a complete task manager. But wait, there's more. Let's dive into expert-level topics. Welcome to Expert Territory. In this lesson, you'll learn the Combine framework for reactive programming. Master publishers, subscribers, and operators for data streams. By the end, you'll handle complex async operations with elegant declarative code. Welcome to Expert Territory. Combine is Apple's reactive framework. Let's master it. Combine is all about data streams. Publishers emit values, subscribers receive them. Simple concept, powerful results. At Published is Combine magic. Every time the value changes, it automatically publishes to subscribers. Chain operators. Debounce waits 300 ms, remove duplicates, skips repeated values. Sync receives the final result. Network requests become elegant. Chain map, decode, and receive. Clean, readable, reactive code. Combine transforms async code. Publishers, operators, and subscribers create powerful data pipelines. You're going reactive. Save data forever with SwiftData. In this lesson, you'll learn Apple's modern persistence framework. Use the model macro, query, and model context for effortless database operations. By the end, you'll persist complex data with just a few lines of code. Save data forever. SwiftData is Apple's modern persistence framework. Say goodbye to core data complexity. @model is all you need. Mark your class and SwiftData handles everything. Persistence, relationships, migrations. One-line setup. Model container creates the database. Your app now has persistent storage. @query automatically fetches data. Model context lets you save. It's reactive. Changes update the UI instantly. CRUD is trivial. Insert to create, delete to remove, just modify properties to update. SwiftData tracks everything. SwiftData makes persistence a joy. No more complex core data. Modern, Swift native, and beautiful. Transform data into stunning visualizations. In this lesson, you'll master Swift charts with bar, line, area, and pie charts. Customize colors, animations, and interactions. By the end, you'll create professional data visualizations that tell compelling stories. Data visualization made gorgeous. Swift charts create stunning graphs with minimal code. Import charts and define your data model. Each data point needs to be identifiable. Simple structure. One chart, one bar mark. X is the category, Y is the value. That's it. You have a beautiful bar chart. Change bar mark to line mark for line charts. Cat-Mull-Rom interpolation makes smooth curves. Beautiful. Color by category. Foreground style groups data. Custom color scales match your brand. Pro-level charts. Swift Charts transforms data into art. Bar, line, area, pie, you can visualize anything beautifully. Put your app on the home screen. In this lesson, you'll build widgets with WidgetKit. Create timeline providers, design glanceable interfaces, and support multiple sizes. By the end, users will see your app's content without even opening it. Widgets put your app on the home screen. Users see your content without even opening the app. Timeline entry is your widget's data. Each entry has a date for when to display, plus your custom data. Timeline provider supplies data. Create entries, wrap in timeline, and the system handles refresh automatically. Widget views are just SwiftUI. Use the entry data to build your interface. Keep it simple and glanceable. Wire it all together. Static configuration combines provider and view. Support multiple sizes. Your widget is live. WidgetKit puts your app front and center. Users love widgets. Make yours informative and beautiful. Hey Siri, let's code. In this lesson, you'll integrate your app with Siri using app intents. Create voice commands, shortcuts actions, and spotlight suggestions. By the end, users will control your app with their voice and find it everywhere. Hey Siri, make your app voice controlled with app intents, shortcuts integration included. App intent defines what Siri can do. Title for display, description for help, parameters for input. Clean. Perform does the work. Add the task, return a result with dialogue. Siri speaks your response. App shortcuts defines trigger phrases. Users can say these naturally. Your app appears in Shortcuts app automatically. App intents unlock voice control. Siri, shortcuts, spotlight. Your app becomes part of the ecosystem. Add maps and location to your app. In this lesson, you'll master MapKit with interactive maps, markers, and annotations. Control camera position and handle user location. By the end, you'll build location-aware apps with beautiful map interfaces. Maps show locations, directions, and points of interest. SwiftUI makes MapKit beautiful. One word, map. That's all you need for a full interactive map. Pinch, zoom, pan, it all works. Control the camera. Position determines what users see. San Francisco coordinates here. Bind it for two-way updates. Add markers and annotations. Marker for simple pins. Annotation for custom views. Make your map informative. MapKit brings location to life. Show places, get directions, track users. Maps make apps powerful. Sync data across all devices. In this lesson, you'll integrate CloudKit for iCloud storage. Enable seamless sync between iPhone, iPad, and Mac with no server code. By the end, your app data will follow users everywhere automatically. iCloud Sync, your data everywhere. iPhone, iPad, Mac, CloudKit makes it seamless. First, enable iCloud and Xcode. Add the capability, check CloudKit, create your container. Apple handles the server. SwiftData plus CloudKit is magic. Add CloudKit identifier and your data syncs automatically. No server code needed. Three databases. Private for personal data, public for everyone, shared for collaboration. Pick the right one. CloudKit is powerful. Your data everywhere. Apple handles the infrastructure. Users love seamless sync. Make your app work for everyone. In this lesson, you'll implement voiceover labels, dynamic type, and accessibility traits. Support users with different abilities. By the end, millions more people will be able to use and love your app. Make apps for everyone. Accessibility isn't optional, it's essential, and SwiftUI makes it easy. Labels and hints. VoiceOver reads the label. Hint explains what happens. Blind users can use your app. Combine elements. Instead of reading icon then text separately, VoiceOver reads them as one unit. Smoother. Dynamic type lets users choose text size. Respect their preference. Your text scales beautifully. Traits tell VoiceOver what an element is. Button, header, image. Correct traits mean correct announcements. Accessibility opens your app to millions. VoiceOver dynamic type, reduce motion, include everyone. Ship with confidence. In this lesson, you'll write unit tests and UI tests for SwiftUI apps. Test view models, verify user flows, and catch bugs before users do. By the end, you'll deploy apps knowing they work exactly as intended. Ship with confidence. Tests catch bugs before users do. Let's write bulletproof code. Unit tests verify logic. Create view model, call method, assert result. If it fails, the test catches it. Test edge cases, add 2, delete 1, verify the right one remains. Assertions catch unexpected behavior. UI tests simulate real users. Launch app, tap buttons, type text, verify results, automated QA. Tests are your safety net. Write them, run them, trust them. Ship quality apps with confidence. The final lesson. In this lesson, you'll publish your app to the App Store, prepare assets, archive your build, and submit for review. By the end, the whole world will be able to download your creation. Congratulations, you are now a SwiftUI developer. The final lesson. Let's put your app in the App Store for the world to download. Prepare your assets. App icons, screenshots for every device size, description, privacy policy. First impressions matter. Archive your app. Select generic device, product archive, then distribute to App Store Connect. Xcode handles signing. App Store Connect is mission control. Create your app listing, upload screenshots, write compelling copy, submit for review. Congratulations, you've completed all 30 lessons from Hello World to the App Store. You are now a SwiftUI developer. Go build something amazing. Thank you for learning with us. This is not the end. It's the beginning of your iOS journey. Now go change the world one app at a time.